All right, next let's try number 12. So again, notice that in this case we cannot solve for y as an explicit function of x. We cannot take this equation and get it in the form where y is by itself on one side of the equal sign. And that's how we know that we need to use implicit differentiation in order to find y prime or dy dx. Now, this also involves products, right? And I don't quite have room up above, so I'm going to write it underneath here. But each side of the equal sign includes a product. So our ultimate goal is to find y prime or dy dx. Our method with implicit differentiation is to differentiate both sides of the equal sign. And now we see we have a product on each side of the equal sign. We're going to have to use the product rule. So I'm going to go right for the gusto here. On the left-hand side, the derivative is first times the derivative of the second. Now, taking the derivative of the sine of x squared requires the chain rule. That is, the derivative of the sine function generally is the cosine function, and I take the cosine of the x squared, but then the chain rule says I also have to multiply by the derivative of the x squared, which is 2x. Make sure you understand that the 2x is not multiplied by the x squared, it's multiplied by the cosine of x squared. That's the first part of the product rule. Then I still have to do plus the second, sine of x squared, times the derivative of the first, and the derivative of y with respect to x is dy dx. Then I take the derivative on the right-hand side using the product rule, so that's the first, times the derivative of the second. Now this second is similar to the second on the left-hand side of the equal sign. In general, the derivative of the sine function is the cosine function, and I have to take the cosine of y squared. But then the chain rule says I also have to multiply by the derivative of y squared, remembering that I'm taking the derivative with respect to x. So the derivative of y squared is 2y times dy dx, and that's actually a use of the chain rule. Okay, so now I once again want to combine terms, I want to get terms that involve dy dx all together on the same side of the equal sign. Whoops, hang on, I didn't finish my product rule. I did first times derivative of the second on the right hand side. I still have to do plus the second sine of y squared times the derivative of the first, and I'll write it here explicitly. The derivative of x with respect to x is 1, but technically I don't have to write that. All right, so just because that might have been confusing, let me just go back over. So on the left-hand side, I used the product rule. I did the first times the derivative of the second plus the second times the derivative of the first. And on the right-hand side, I did the first times the derivative of the second, and I almost forgot, plus the second times the derivative of the first. So something for all of us to watch out for and keep in our mental filing cabinet is when we have these more involved questions to follow through and make sure that we're completing everything. All right, so I want to gather up all the terms that involve a dy dx and get them together on the same side of the equal sign. So on the left side, I already have a sine of x squared times dy dx, and on the right side, I have that other term outlined in orange that I want to subtract over to the left-hand side, and I'm going to rearrange the terms to make it a little easier to look at. So that would be minus 2xy times the cosine of y squared times dy dx. And then, on the right-hand side of the equal sign, I want any terms that don't involve a dy dx, so I already have one of them over there. That's the sine of y squared. That's already on the right-hand side. And then, the first term on the left side of the equal sign, because it does not have a dy dx, I want to subtract that one over to the right-hand side. And again, I'm just going to rearrange the terms a little bit there. Minus 2xy times the cosine of x squared. All right, now I want to factor a dy dx out of the left-hand side because that is what I'm actually trying to find. And anytime I do a factoring like that, I always look back and try to distribute back through the parentheses and make sure that I didn't forget anything, or make sure that it multiplies back through the way it should, and it looks like it does. I don't have anything to do on the right-hand side except rewrite it. I don't have any like terms that I can combine. And then my last step is to divide both sides by what's being multiplied by dy dx on the left side. So again, my ultimate goal is finding dy dx, or y prime, the derivative of y with respect to x. So I'm going to rewrite the right-hand side. And then I'm going to divide by that entire bit in parentheses on the left-hand side. And Bob's your uncle. So this is my final answer. All right, so again, the big picture goal is still finding the derivative. Now we have these functions that include x and y mixed together in such a way that we cannot solve for y. So when we take the derivative of any term that involves a y, we have to think about the chain rule and multiplying by dy dx.